Number 60. How much of a single-stage rocket that is 100,000 kilograms can be anything but fuel if the rocket is to have a final speed of 8 kilometers per second, given that it expels gases at an exhaust velocity of 2.2 times 10 to the 3 meters per second? All right, so first thing is we have to think about what formula to use. And looking through the textbook, right, you would find this particular formula, that the final velocity will equal the exhaust velocity multiplied by the natural log of the initial mass divided by the final mass. So now, what's the question asking? The question is asking us how much of a single-stage rocket can be anything but fuel, right? So basically what they're asking us is what could be the absolute final mass of this thing, right? Because the difference for the rocket to go from an initial value of, let's say, 100,000 kilograms to, let's say, a final value of, 90,000 kilograms, that meant that 10,000 kilograms must have been fuel, right? So basically what I'm after is I'm after the total final mass that this rocket can attain. So therefore, I'm going to solve the equation for this variable, right? Dividing out v sub e from both sides would be v sub f divided by v sub e will equal the natural log of the initial mass divided by the final mass. Getting rid of natural log, you have to raise both sides up to the e. All right, so I'm going to raise this side up to the power v, raise this side up to the power v. And what happens is the e and the natural log cancel. So now this is going to be e raised to the vf over ve is going to equal mi over mf. And now we just have to solve for the final mass here. So you can just switch these two variables there. Basically a cross multiplication, just kind of condensing it into one step. So this is the initial mass then over e raised to the vf over ve. This is the equation. Just plug it all in now. So mf will equal the initial mass, which they told us was 100,000, all divided by e raised to the final velocity. Now recall though, they gave it to us in kilometers per second. We need it in meters per second. So just take that value, multiply it by 1,000. So that's going to be 8,000, all divided by then the exhaust velocity of 2.2 times 10 to the third. Okay, and what do we get? Let's see. 100,000 divided by second e, 8,000 divided by 2.2 times 10 to the 3. And there we have it, right? Considering sig figs, we got 2.63 times 10 to the third, right? And that is in kilograms. Okay, so that is the actual mass of the rocket. Okay, and then the difference between the 100,000 kilograms and the final mass here would have been the fuel amount if they had asked for that. Guys, thanks so very much for tuning in. Please remember to subscribe, and I will see you in number 61. Take care.